Today, we are going to break down in detail how to prepare your mobile device for fully autonomous operation, transforming it from a simple entertainment device into an independent knowledge base, a high-precision navigator, and a failure-resistant emergency communication station. What you're about to hear are not mere theoretical speculations or generic advice, but a practical and strict protocol of technical actions verified by professionals in critical environments. In today's hyper-connected world, we have become dangerously accustomed to relying on cloud services for almost everything. Our contacts, our daily routes, instruction manuals, and all our personal information reside on remote servers that we assume will always be there. However, in a scenario of large-scale power outages, critical network infrastructure failures, or the blocking of specific segments of the internet, that dependency will instantly become a technological trap. The goal of this protocol is to teach you how to utilize that potential at 100%, without unnecessary emotions, basing ourselves solely on technical facts and proven engineering solutions. Offline satellite navigation. The first thing an unprepared user loses when the network suddenly disappears is spatial orientation. Without access to the network, we lose the sense of where we are and, more seriously, where we must move to find safety. We are conditioned for applications like Google Maps to function by constantly loading data in real time. In unusual conditions, or far from urban centers, that approach is unacceptable and dangerous. It is critical that you understand the physics of the process. The GPS module in your phone is a purely passive receiver. This means it receives signals directly from satellite constellations in orbit and does not require a cellular signal, Wi-Fi networks, or an internet connection at all to determine your exact coordinates. The real problem is not the signal, but the absence of the physical map in the phone's memory onto which those coordinates can be projected. To solve this, professionals in the sector use applications based on OpenStreetMap data, such as OsmAnd or organic maps. Unlike commercial services, these tools were designed from their origin to work locally and allow for the download of detailed cartography of entire countries in vector format. Vector graphics are essentially mathematical formulas and not bitmap images, therefore, they occupy 10 times less space than traditional satellite photos and maintain absolute clarity no matter how much zoom you apply. Your action algorithm is as follows. Today, as a preventive measure, download the maps not only of your city, but of all surrounding regions and provinces at their maximum level of detail. If you decide to use OsmAnd, it is mandatory to go into the settings and activate the contour lines and nautical map layers. This will allow you to clearly visualize the terrain relief, changes in altitude, and the approximate depth of water bodies. Information that is vital if you are forced to move on foot or off main roads. Do not forget to mark key points of interest. Your home, your family's meeting point, and potable water sources. Remember that a 500 megabyte file, downloaded in time, can save you hours of uncertainty when cell towers stop transmitting. The library at the end of the world. The second major problem during a network collapse is the instant loss of access to human knowledge. In everyday life, we have delegated our memory to search engines and artificial intelligences. But, in an information blackout, you will not be able to consult the dosage of a specific medication, nor search for a schematic to build a homemade water filter, nor refresh first aid protocols in case of an emergency. This vulnerability must be resolved preventatively. The definitive solution is the Kiwix project. It is a free software that allows you to open and browse massive websites in a special compressed format called ZIM, without the need for a single bit of internet connection. With Kiwix, you can download literally all of Wikipedia in English onto your phone. For example, the entire segment of articles in our language, without images, usually occupies between 30 and 35 gigabytes. At first glance, it may seem like a considerable volume of data. But let's be realistic. Today, microSD memory cards of 128, 256, or even 512 gigabytes, are extremely affordable. These cards allow you to carry in your pocket not only Wikipedia, but also the complete archives of WikiHow, professional medical manuals, technical literature libraries, and translators that work entirely offline. Your priority when configuring this storage unit must be first aid, security fundamentals, machinery repair, water purification, and applied botany. Having this structured database physically transforms your smartphone into a universal library that is always with you. However, keep in mind that downloading these volumes of data requires time and a stable connection. Therefore, you must start the downloads right now while the home network infrastructure is functioning normally. Mesh networks and decentralized communication. When the centralized cellular network becomes inaccessible due to saturation or lack of energy, classic messaging services die. However, inside your phone, there are Bluetooth and Wi-Fi modules that we normally use for accessories, but which have the capacity to talk directly to other devices within a radius of 50 to 100 meters. The so-called mesh networks are based on this physical principle. The most robust and proven software solution for this is Briar. Its main competitive advantage is that it uses absolutely no central server. All messages are transmitted in encrypted form directly from one smartphone to another. If you find yourself in an apartment building or in a large group of people, Briar will automatically create an invisible local network. In this network, each device with the application installed functions as a signal repeater. The more nodes or phones there are in the area, the greater the resilience and range of the network. The message will jump from phone to phone until it reaches its final recipient. If you need communication at much more serious distances, there is Meshtastic technology. This requires a small piece of external hardware, a low-cost radio module under the LoRa standard. This module, about the size of a matchbox, connects to your smartphone via Bluetooth. The combination of your phone and the LoRa module allows you to send text messages and exact GPS coordinates several miles away, consuming an insignificant amount of energy. It is, in fact, your own private and independent digital radio, protected by modern encryption. This is the highest stage of communication autonomy, a technology that is legal and accessible to any user who decides to prepare today. Power management and hardware survival. All this infrastructure of maps, encyclopedias, and radios will be useless if your battery dies in 5 hours. In an autonomous environment, the philosophy of smartphone use must change radically. The biggest energy consumer is the screen backlight and the constant search for non-existent cellular networks. Your strict energy-saving algorithm is 1. Put the phone in airplane mode immediately. This turns off the modules that search for signal towers, a process that, when the signal is weak or non-existent, forces the phone's processor to work at maximum power, draining the battery in a matter of minutes. Bluetooth or Wi-Fi modules needed for mesh networks can be turned on individually, without exiting airplane mode. 2. Activate extreme power-saving mode. Limit all background processes and leave only critical tools active: the GPS navigator, Kiwix, and your decentralized messenger. 3. Use dark themes exclusively. If your device has an AMOLED screen, the color pure black means the pixels are physically turned off. A deep dark theme can save up to 30% of battery energy during text reading. Additionally, it is highly recommended to have a second backup smartphone. It does not have to be a high-end device. A reliable terminal with a large capacity battery is enough. In the event that your primary device suffers damage or is discharged, you will have a substitute ready for immediate operation. Technical audit. Do not see these tips as an exaggerated precaution, but as a necessary technical audit for any unforeseen scenario. Your smartphone is either an expensive toy or a powerful tool for survival. The difference lies solely in your preparation. If you value technical and verified information on security and autonomy, subscribe to the channel and like this video. Your comment helps us continue creating useful content. Keep a cool head and act rationally. See you in the next one.